If 100,000 charge cycles truly translated into a century of real-world use, then why is no electric vehicle manufacturer willing to warranty a battery beyond 10 or 15 years? Tesla, BYD, CATL, LG, Energy Solution. All of them publish detailed cycle life data, yet none are prepared to bet on batteries lasting for multiple decades. The gap between laboratory numbers and real-world commitments is exactly where the illusion begins. When battery companies like Donut Lab announced the headline figure of 100,000 cycles in early 2026, they were describing the endurance of electrode materials under ideal laboratory conditions. But a battery is not an inert block of metal. It is a living chemical system. From the very moment it leaves the production line, degradation reactions inside the electrolyte begin. No charging, no discharging, no use required. Time itself is already a destructive force. Real-world data from Geotab, based on analysis of more than 5,000 electric vehicles across the United States and Canada, shows that EV batteries lose on average about 1.8 to 2.3% of capacity per year simply due to the passage of time. This degradation is not caused by fast charging or abusive user behavior, but by slow oxidation reactions that erode separators, consume active lithium, and increase internal resistance. Even if a car is parked in a climate-controlled garage, after 20 to 30 years, the polymers, binders, adhesives, and insulation materials inside the battery pack will inevitably deteriorate. A battery may survive 100,000 workouts, but it cannot escape the aging laws of time. So what is the real enemy of EV batteries? It is not the charger. It is not the cycle life number printed in bold on a brochure. It is the present moment. Specifically, the ambient temperature the vehicle lives in every single day. This leads to an uncomfortable question. Why does the same Tesla Model 3 or BYD Han lose capacity faster in Arizona or the UAE than in Norway or northern China? The answer lies not in user behavior, but in chemistry. High temperature is the poison that neutralizes every theoretical cycle life figure, including 100,000 cycles. Operational studies in the United States and China show that EVs operating in hot climates experience battery degradation roughly 0.4% faster per year than those in temperate regions, even under similar usage intensity. That number may sound small, but ask yourself, after 10 or 15 years, how much capacity does that gap quietly erase? From a physical standpoint, elevated temperature accelerates every parasitic reaction inside a battery cell. Electrolytes decompose faster, the SEI layer grows uncontrollably, and active lithium becomes increasingly trapped. More critically, sharp crystalline structures, often referred to as dendrites, can form and propagate, piercing separators and creating microscopic internal short circuits. These processes occur continuously over time. They do not require fast charging, they do not require deep cycling, and they do not care how many unused cycles remain on paper. So the next question becomes unavoidable. What does 100,000 cycles actually mean when time and temperature are silently eating away at the battery every day? Even with world-class thermal management, physical limits remain. The case of Hans-Jörg von Gemmingen, whose Tesla Model S surpassed 1.6 million kilometers, is often cited as proof of extraordinary battery durability. But a closer look tells a more nuanced story. To reach that distance, the first battery pack was replaced at around 746,000 kilometers. This is an impressive milestone, but it also raises a reverse question. If batteries were nearly immortal, why did replacement occur well before 1 million kilometers, even with Tesla's best-in-class thermal control? And the story does not end with the battery. Let's perform a brutally simple calculation. Assume an EV can travel 400 kilometers per charge. With 100,000 cycles, the theoretical lifetime distance becomes 40 million kilometers. Now comes the question no one likes to answer. Do you genuinely believe a car's chassis, suspension, body structure, and mechanical systems can survive 40 million kilometers? Even in Gemmingen's case, while the battery was replaced only once, the electric motor and drivetrain were replaced 8 times. For conventional vehicles, fleet data from United States and Chinese service operators shows that structural fatigue and system-wide degradation typically become serious after about 300,000 to 500,000 kilometers. owning a battery that outlives the vehicle by tens of times is like transplanting an immortal heart into a mortal body. The shell of the car will disintegrate long before the battery reaches even 20% degradation. So the real question is this: are we optimizing batteries for cars, or for something else entirely? Operational data from Tesla ride-hailing fleets in the United States and BYD electric taxi fleets in Shenzhen shows many vehicles exceeding 150,000 to 200,000 kilometers, with only about 1 to 2% battery degradation. This leads to a concluding question that is hard to ignore. Have modern EV batteries already become over-engineered relative to the actual lifespan of a car? And if 100,000 cycles will never make a car last 100 years, what exactly are battery manufacturers racing toward? The answer lies in circular economics, not in the experience of the first vehicle owner. The true value of ultra-high cycle batteries does not reside in the first 10 to 15 years of vehicle life, but in the full material life cycle embedded within them. When an electric vehicle retires after 12 to 15 years, its battery is often far from dead. Instead, it enters a second life. Projects like Nissan's Pioneer installation at Fiumicino Airport in Italy, which repurposed used Nissan Leaf batteries into a 2.1 megawatt-hour energy storage system, or large-scale grid storage deployments in California and China using retired EV batteries, clearly demonstrate this role. And here, the final question emerges. If not for these second and third lives, what would 100,000 cycles really be worth? 100,000 cycles is not a promise of a 100-year car. It is a promise to the planet. It ensures that the lithium and cobalt we extract will serve humanity across multiple decades and multiple applications. Rather than ending their journey in a landfill after a single vehicle lifetime, only when that number is placed in this context does it finally make sense.